Transformations of functions. So before we begin, let's just review our basic rules. If we add a number outside of a function, then that function will translate up 2 units, or however many I add. For example, if I subtract 2 from a function, then the function would move down 2 units. But adding or subtracting to the x value inside of the function would move the function left or right by as many units, such as 6. So plus 6 actually doesn't move it to the right 6, it moves it the opposite way, which is left 6. Now x minus 6, instead of moving it left, actually moves it right. So we ought to remember to change the sign of what's inside in order to know which way it moves left and right. Now, if we negate a function outside, it will take the y values and negate them, and that would make them all negative, and it would reflect it over the x-axis. But if I negate an x value, for example, if I negated this x value 2, 4, I would negate it to negative 2, 4. Negating an x value would reflect over the y-axis. So those are the basic rules here. So how would I go from a graph of x squared to a graph of this dotted line? Well, it is going left 3 and down 5. So which of these equations shows that a parabola x squared has gone left 3 and down 5? Well, it is going left 3 and down 5. So which of these equations shows that a parabola x squared has gone left 3 and down 5? An x value would reflect over the y-axis. So those are the basic rules here. So how would I go from a graph of x squared to a graph of this dotted line? Well, it is going left 3 and down 5. So which of these equations shows that a parabola x squared has gone left 3 and down 5? Well, the down 5 should be subtracting 5, right? If I do minus 2, it was down 2, so minus 5 should be down 5. So these are both down 5. So which of them effectively goes left 3? Well, to move left some number of units, I actually add that number inside. So though the minus 3 might look like the vertex, negative 3, negative 5, we would change the sign of that negative 3 to a plus 3 because we move the opposite direction. So seeing the plus 3 makes it go left 3, and then the minus 5 makes it go down 5. This case, very similar. We're having an absolute value function, but we're just calling it f of x. So if we went left 2, up 1, the left 2, we should change that to a plus 2. So we do plus 2 inside the parentheses, and then up 1 would be to add 1. We do not change the sign of the up 1, we just add 1. So the x plus 2 would move left 2, and the x plus 1 would move up 1. Here I do see a reflection. So let's see. If I have a regular v, which looks like this, if I want it to go down like this, I will need to reflect that over the x-axis. So I first reflect it down. Now, how do I reflect over the x-axis? Well, here in our rules, we said if I put a negative in front of the function, it reflects over the x-axis. So that's what we want to do. So where do I put the negative? I don't put it on the x, I put it out in front. Now, how do I move left 2? Because after I have reflected, I'm going to want to move it so that the point of the v is at negative 2, so I need to move 2 units to the right. So plus 2, sorry, I need to move 2 units to the left. Plus 2 should go 2 units left because it is opposite. So since that point is at negative 2, it's an x-coordinate, I change it to a plus 2. So this would be the appropriate equation. The negating would reflect it over the x-axis, and the plus 2 would move left 2 in order to make the graphs overlap. Here, I'm seeing a little bit of a symmetry here. So I'm seeing the peak is far from the x-axis, and this peak is also far, from the y-axis. This peak is far from the y-axis, and this peak is far from the y-axis. So if I took this and reflected it over the y-axis, it would roughly align. Now this is the point negative 7, 4.5. So it would reflect over here to roughly the point positive 7, 4.5. But then it would need to go down 2 units in order to match up there. So how do I reflect over the y-axis? Well, to reflect over the y-axis, we would negate the x value, right? Because if we have -7 and negate it, we get +7. So we're going to negate the x value, which is going to be one of these. But after we reflect it, we must go down 2 units to match the dotted graph. And to subtract 2 would go down 2. So the adding and subtracting outside goes up or down the way you would expect. So let's look at the picture. The first negating of x reflects over the y-axis, and then the -2 makes the graph go down. Exponential graphs can be a little trickier. I recommend looking at the asymptote. So the black graph right now gets closer and closer and closer to the x-axis. So clearly the graph has gone down 1 unit because it's now getting closer and closer to the line -1. So I need to choose the point that goes -1. So it's going to be one of these because they're going to go down 1 unit. These ones would go up 1 unit. But what else do I need to do? Besides going down 1 unit, if I went down, this 1 would be a 0. I then need to go 1, 2, 3 points left to touch the graph. So this point at 0, 1 translated down 1, left 3. How do I go left something? I add that amount inside to the x. So which of these do I want to choose? I actually want to choose this one because the +3 will make it go left, which is the direction it needs to go to match the orange graph. So first we'll do the left 3, and then we'll do the down 1, and then that will completely match the graph I was looking for. Now this one is going to involve some sort of reflection. So if the graph as current, let's see, if the graph as current gets closer and closer and closer to the x-axis like this and goes up, 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 well, this one's going down, 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 down. So first thing I would do is reflect over the x-axis, which would be to negate all the y values. Now I'm going to look at this point right here, which is the point 0, 1. Right there is the point 0, 1. So if I reflected that over the x-axis, it would be here at the point 0, -1. So a simple reflection will negate the y value. But then it must have moved right 1 unit in order to totally overlap here. So we are going to negate outside. Now the +1 inside the exponent will actually make it move left. So not only should we negate outside and front, but we should do -1 because -1 will make it go to the right. So the negation will flip it, but then see how that point 0, -1 should move to 1, -1. That was a rightward motion. When we move right, we should subtract a number from x.